As the title says, this talk is about putting containers in your pipeline. This is an introductory talk. This is about a team that took their first steps to using containers in a pipeline. So don't expect any fancy stuff. This is the cloud native track, so there's still time to leave the room if this is going to be too basic for you. My name is Kris Buytaert. I've been talking at conferences for the past two decades, I guess. Somewhere along that history, I started DevOps Days together with Patrick Dubois, and since then everybody calls DevOps the new problem. In my day job, I work for Inuits. We're an open source consultancy company in Europe. We have offices in Belgium, the Netherlands, Czech Republic, and Ukraine. And what we do is we help people deliver software, build software with open source tools. So yeah, I run DevOps Days globally. I run a couple of other conferences. So I talk a lot about this kind of topics. So who knows what DevOps is? 2.5 hands. Or are you just all way too afraid to who's awake? Who's a human being? Okay, this is Germany, you don't interact that much, but it's better than China. I mean, China, you get the answer 2 minutes later because of simultaneous translation. So, DevOps. As I said, I started this conference by accident back in 2009 when Patrick Dubois and I were talking about how we went to conferences where we talked about operation stuff, how we went to conferences, how we met a lot of people there on the development part, but there was no conference there where we were actually bridging the gap where people from both sides of the audience were present so we could discuss the real problems we had, which was deploying and delivering software. There was velocity in the States, but in Europe there was pretty much nothing. So we had the crazy idea to run this really small conference, and we did that in Ghent in November 2009, and we had like 69 people there. And 2 weeks ago we went to Beijing and there were 1,200 people there, so it's completely crazy. That's how DevOps Days got started. That's how DevOps, the movement, got started. And when we talk about this thing, there's Damon Edwards and John Willis who were running their podcast, the DevOps Cafe, and they were interviewing a bunch of people. And from those interviews, they came onto 4 key components, which for them meant DevOps. It was about the culture of the organization, how they dealt with their people, how they took on projects, how they looked at working together. It was about automation, and a lot of what we're going to talk about today is about automation. It was about measurement and monitoring and metrics, and it was about sharing those experiences. So, if we talk about DevOps, there's a lot of people who say that the ultimate experience is to do continuous delivery. There's some truths in that, but what we really want to achieve there is that we can basically take a piece of software and then we can deploy that automatically where there's no human involvement, and that we do that through collaboration, through automation, through developers and operations people working together, and that we actually can get a change in a piece of software to production in a matter of minutes rather than hours or days, or if you work with large organizations, governments, banks, and a couple of those, which I've been working with for the past 5 years, months, and sometimes even years. And that's the change, that's the premise a lot of people are looking into when they want to take that journey towards adopting DevOps. So this talk, I'm going to say this again, it's really about a team that had a deployment problem and figured out, hey, what if we try this for the very first time with containers? It was a team that was pretty advanced in doing infrastructure as code, mostly Puppet, everything was automated. They could spin up machines 10, 15 identically. They had clean roles and profiles patterns for the people out there who are familiar with Puppet. But they had not yet used containers or Docker. So this was their first journey in there, and figuring out why they did it and how they did that. So what they were doing was basically build a pipeline. If you look at continuous delivery pipeline, if you look at CI pipeline, the idea is you check in code, in version control, you build and do some unit tests. If that fails, you basically go back to the first phase, and you keep trying till every single part is green. Trust me, there's people who just, hey, fix this and go further, and forget about all the other tests, and then figure out later in the pipeline that they actually fixed the wrong test or introduced more bugs than they fixed. If you do this with Jenkins, you can get things like this. So yeah, that's another thing. They have a lot of Jenkins in place. They had a lot of manual work into actually setting up that Jenkins, and that's also a problem they were trying to tackle. So this is an example of a very green working and very old Puppet pipeline in Jenkins. Well, it's a screenshot from 2012. So deploying software and being able to do that continuously. If you look at the release notes from Deploy Nature from Etsy, back in 2010, they said that this is something that we should all agree on. The ability to deploy software stably, quickly, and safely, that's something that if you're working with an operations team and with a development team, you should not be discussing. That should be a given. And that's the main problem behind the continuous delivery point. You want to be able to say at any point in your software delivery trajectory, push to production. We know that we have a version which is stable. We know that we are doing this. We've been doing this before, and we don't need 20 people in a room on a Friday evening to actually fix this. So that's kind of a challenge that people had. So in order to do that, people are looking to find an artifact which they can take from development all the way to production and to all the different other stages, shadow production, acceptance, disaster recovery, and that artifact should be unmodified. It should be the same all over. There could be config there that's added to that artifact, but the binary should be identical. So from an ops point of view, we like to package stuff. Typically, we like to package software as an RPM, as a Debian package, because it gives us that security that we know that that package has not been modified. The number of organizations I walk into where the deployment is still happening, so we generate a jar, and then we copy that jar onto a file share, and then somebody else copies that file to another file share, and then it's running in production, and they're absolutely not sure if that thing which they've just copied over a Samba file share to a server is actually the thing that just got tested or built by a developer or just put in place randomly by somebody. It's still current reality. This team was already a bit more advanced. They could actually build packages, deliver packages, and make sure that they got deployed. And they got, by using packages, they got consistency, they got security, they got the dependencies. And if a file is modified on a file system, your package management system can tell you. They could uniquely identify where the package was coming from, how it was built, because the metadata had information about how most of the packages were built. There's a bunch of other reasons why they do that. So when we started that project, they had a lot of things in place already. But the biggest challenge they had was tools like Ruby packages, Python packages, PHP, where they were not having a consistent build, where developers were frequently randomly taking stuff from the internet. They had huge dependency chains, and they were trying to fix that. And one of those packages, one of those tools was actually Dashing. Who knows Dashing? Who's using it? Okay. So Dashing, likes this picture show, allows you to build dashboards, allows you to take information from a lot of data sources. This is actually a screenshot from one of our production stacks, which shows a number of things about Jenkins builds, a number of things about different Foreman stacks, a number of King App platforms, and this is actually data coming right out of Graphite. So you can build that and give every team a dashboard which they want to use, which they like to look at. So we've been using Dashing for quite a number of years now, and suddenly we came to the realization, well, this project is dead, there's no development on it anymore. But nothing is more true, it's actually been forked, it's been renamed by now, and development is still going on. But it was kind of the at the moment that we started this project to automate the deployment of dashing completely, that this happened. So it's kind of weird. Now, there's a couple of things I really like about dashing. There's a couple of things I really hate about dashing. The good part is there's a huge community out there with a lot of widgets, with a lot of things you can just find on the internet. It's easy to debug. It's pretty simple to write additional modules in. That's good. The bad thing is, in order to deploy it, you're in Ruby gem hell. There's really weird ways they think about deployment, and a lot of the configuration is actually in the code. If you look, for example, at the way these different Ikingas are being monitored, they're actually the list of API endpoints where they have to query is in the code. It's pretty ugly. And then it goes on. I mean, you do gem install dashing, and suddenly, 5 to 10 years ago, we said, hey, if you do Maven build, then you get the whole internet. Now the same thing is happening with both Python, with Ruby, with Symfony packages, with Composer. All of those things are just the new internet, and the new Maven, sorry. So we wonder about reproducibility. We wonder about how can we even ensure that if we build it tomorrow, it's going to be exactly the same. So in this organization, typically, their style of deployment was, we package everything. They're a rel central shop. And a lot of those packages were not up to distribution standards. They had no incentive on building their own software and shipping that to an upstream distribution. So they built those packages with FPM. They were built by Jenkins in a job and uploaded to Pulp, which is an RPM repository. And they had a bunch of manually created jobs in Jenkins to do this. The config was completely managed by Puppet, and the service was also completely managed by Puppet. So they pretty much lived up to the PCS pattern, PCS being package config service. But now the thing was they needed to have a build environment for a Ruby package. And we knew up front that this was not going to be the only Ruby project. And for dashing, we had a bunch of specific dependencies. We needed 2.1. We already knew there was another project coming up that was going to need a totally different Ruby version. They have been doing some experience with building stuff in a Shroot. There was ideas of spinning up a Jenkins slave for every single variant of this. And it was like, what if we tried doing this in a container? Because we can spin it up, we can build everything in there, and when it's done, we just throw it away. And it actually took about a week and a half of discussion to get the people convinced that this was maybe the first project to start trying this in a container, because they had not really a use case to use containers yet. So we're going to do this in containers. So we need to build a bunch of pipelines, a pipeline for dashing, a pipeline for the actual dashboard, so that we could deploy the dashboard and dashing itself independently, because the dashboards people were working on were going to be more frequently updated than actually dashing as a software. And what we saw previously is that people, well, they were deploying dashing, but then they were logged onto the box and they modified the dashboards and the templates and all the scripting in between. And somebody else then used version control and everything got overwritten. So we needed to have a way that when we put something in Git, it was being committed, was being tested, and moved to production. Because the other thing we figured out is while those people were hacking in production, they often made simple Ruby errors or missed out gems that they started depending on, and suddenly the whole dashboard started failing. So we needed also to have a test environment which we could easily spin up and test the application with. The Jenkins stack when we started out was pretty simple. It was a brand new Jenkins, because this one was the one we were going to use containers on. And together with introduction of containers, we also said we're not going to allow manual job creations on this anymore. I'll come back to that later. And we also said there's going to be a development Jenkins where we build jobs. And once those jobs are really stable, we're going to move them to a production Jenkins where we're going to have completely different applications, all fully generated, building those things. So we had one master where there was no jobs running and multiple slaves. And the goal was to build a fully reproducible pipeline. So How did it start? We started out with basically an empty container. We took the upstream CentOS container because, well, the shop was running CentOS, and we were going to package RPMs, so we needed all of those dependencies. So that's what we started from. We added FPM to it. With the Ruby dependencies, we added repositories for EPEL and all the build dependencies for all the Ruby packages. And then we started experimenting with actually getting this to work from Jenkins. There were a bunch of plugins in Jenkins that allowed you to do Docker builds. But when they tried it, actually none of them really worked. So what happened is that they just started triggering those builds, and those run from trivial shell scripts. One of the things that didn't work was, for example, was a pretty enterprisey environment, actually a government agency, and they required HTTP proxies to be passed to everything. So even in the container, they needed to go through an HTTP proxy to get the gems from everywhere. And there was no way we could actually configure that from Jenkins, from the UI, from the plugins. That was pretty much of a problem. So simple, empty container, starting from the first one they actually built, set up in a Jenkins Docker manually, and then they realized, oh, but we're going to add more slaves. So we needed to automate actually the deployment of Docker also. So these are the insecure registries and the registries added, which I'll come back on later. So they built a basic empty CentOS container as the basic start for everything we're going to build. Then you wonder from an operations point of view, I need RVM. How am I going to have RVM installed? There's no packages. There's documentation which basically says, oh, just curl this from the internet. And you look at it like, no, this is not how I want to deploy software. Andrew Clay Schaefer at Config Management Camp 2.5 years ago called this having unprotected sex with the internet. And that's kind of what they were doing. And we said, okay, so either we're going to work around this completely, or we figure out, well, it's a container, we're going to throw it away. You know, YOLO, let's just do this. And we ignored it. So we had the first container, the second step already, the second layer, which was a container image with RVM. Then the second one we added was, well, we need this specific Ruby version. We need Ruby 2.1. And we built a package out of that. And then we added another version. And we started adding bundle. We started adding dashing and all the dependencies. And at the end of this, we actually had RVM-based environment, completely contained, with the right Ruby version for this platform, where there was an empty dashboard which was running, and all the dependencies based on a bundle install into that platform. So we had a reproducible container which would show an empty dashboard, which we could FPM and then deploy somewhere else. So now we had like 4 layers on top of each other, and we rebuilt this thing like once or twice, and we figured out, well, what if we put all the steps in there? We get a smaller image, we get less layers. It's going to be much more economic to do so. So we killed a bunch of those layers afterwards and actually did most of those steps in one. So now we had an empty container running dashing. The next thing is we needed to have a reproducible way of getting all the small widgets from dashing into that environment. And then there was more. The way you get a widget and the way people publish widget on GitHub is basically by publishing a gist. And you get a gist ID, and that's how people share their code. You see the double face palm there, right? That's even more unprotected with the internet. So we're like, we cannot do this. We need to version this. We need to actually get those files in there, create local repositories, fix all of this, and that would be yet another way how to do those pipelines. So There was another container that was based on the same. We took the container we just built and we started actually deploying the code for the dashboards into that container. We cleaned up a bunch of things because we didn't want to default the Ruby libraries for Twitter there. And again, the same exercise. New code, new gist, new Ruby dependencies. So we needed to have bundle install, get all the dependencies from the internet, and build that. So we had 2 packages now. We had user local RVM with all the dashing code and the dependencies, and we had the local dashing directory with the actual packages. So what we could do then is take those RPMs, install them on a traditional server, and tell developers, hey, we just deployed this. Go to that link and test if it's all right. That's what most of the Java developers were doing back then with all of their applications. They just deployed to the next phase. But we figured, well, we're doing this container thing now. What about we take it one step further? What about we just take the packages we just built, build a container with it, spin up that container, and test if actually what we want to get is in there. So that's what we did. We built that container with the most recent dashboard based on the actual RPM artifacts that were built. And we just ran it, and we figured out if it's going to work. The first test was just a wget on a port, and if that gave a correct return, then everything was working, and we weren't sure about the layout, we weren't sure about the content, but at least we knew that there was a dashboard showing. And that was already an improvement for that team based on the previous steps. So not only they were using container to build their artifacts that they were going to ship, but they were also going to now test their artifacts in that container. The actual deployment of the artifacts was still done via mcollective on different virtual machines that were still completely managed by Puppet. So when an artifact was built, those 2 artifacts, the gems and the dashboard, what they did for first the acceptance environment and then the production environment, so this is for the production environment, they basically told over mcollective, which is an orchestration tool which works really nice with Puppet, on all of the machines with the profile dashing, update me these packages, and that then happened simultaneously. So they had solved a bunch of those problems, but not all of them. I told before there's a Jenkins master with multiple slaves, and after a couple of days, they added more slaves because the initial setup had like 1 slave and everything worked fine. And then they're bumped basically into the next problem. If you build the container on one node and then you run the test job on the other node, you don't have the same image always. You might not even have that container locally on that machine. So we figured out that we needed to introduce a local repository. Because this was not open source code. This was not code that we were going to publish somewhere on Docker Hub. This was really code that we wanted to have internally and not being shipped. So in the build, each container that was built, there were steps added that were going to push packages to the local repository, images, sorry. The pattern they had for a lot of the RPMs and the jars and the vars was that they had isolated pulp repositories for development and for production. So in a staging environment, they upload to one repository. In a production environment, they upload to another repository. And they wanted to keep doing that same thing with the Docker images. So they needed to have a way that on the Jenkins level, the jobs were identical, but still the Docker push would end up on the right repository. And that's what's in this config. These are Puppet parameters. This one is hard-coded as an example, but these were basically pulled out of Hera, and depending if the Jenkins was a production or an acceptance box, the default registry to where a push was happening was being changed. Now this is interesting because upstream Docker doesn't like that. Upstream Docker thinks you should not be using an internal repository. Upstream Docker actually thinks that you should be using their repository and pay money for that. So we needed a local repository, and we looked at a couple of alternatives. We already had Pulp in place, but when we did the research, Pulp was not capable of actually allowing you to push images to it. It could be perfectly working as a local mirror, but you couldn't push your own content in there. We looked into Nexus Artifactory, but given that this was the Linux team and not the Java team, those people were really not that interested in actually adopting Nexus for that. There was a Docker registry which you could run as a container. And the question from a lot of the people there was, we're just slowly getting into this journey. Do you really want to have a piece of software where we're going to heavily depend on, already run on a platform that we don't really know yet, that we don't really know how to manage yet? So there was a lot of reluctance of running the register actually as a container. Luckily, Docker distribution had packages available in, I think it was in EPEL, so it was pretty easy to set that up, and that's what they settled for. I know at least of one team who's now thinking about moving their images to Nexus because they already have a Nexus and they're using Nexus for their Java, their Python, and their Ruby stuff already, so it makes sense for them to just add Docker containers there. I'm not sure how far they are with it, but they were evaluating that. So, there were a couple of things where we bumped into that weren't really funny. The search path for images, I want to push to a local repository, I want to get those things first. Configuring Docker to, by default, go to my registry first. Apparently, Docker Inc. has pretty solid IDs on that that should not be done. Red Hat, however, thinks that that is something you should do. And a lot of other people are kind of in the field of Red Hat where they say, well, corporate networks don't always have full access to the outside. We want to have full control over what's happening. So that's a fun thing. The parameters to give to a container to use proxies internally, set those environment variables, have been changing over the different versions. The Docker and the Red Hat implementations, they differ. So those were a couple of things that people had been struggling with. Works on my machine, as opposed to works on the infrastructure, because, well, there's a different version and there's a different parameter to be used. And we got bitten by a bunch of those quite a lot. So with this in place, there was a bunch of problems solved. We now have shrouded packages built. There's no complex mocks, and people are not writing spec files. They have an internal Docker repository, and they can actually reuse those images. And we kind of have the first stage of Jenkins and Docker integration. The next phases and the next things they started doing is actually take this pattern and do that for more and more applications. Python, PHP, and also add the thing where originally when they had an application which was written in PHP 5, can you spit up a new version with PHP 6 or 7 and try this? And what we now can do is actually have containers running next to each other, running tests of future versions based on the same code base, and even look at what the next version is going to do. We did it for Puppet code, we did that for PHP code. So rather than having different virtual machines, different full images, we're capable of running those tests. We now have containers that spin up and where the tests are running, and which we decommission once we don't need them anymore. So that actually brought us to another problem, which I'm going to try to go over really fast because we don't have that much time, which is the manual clicking in Jenkins and the creating of those pipelines. And the adoption of pipeline as code, which, however you're going to start building pipelines, if you're going to build them straight in containers or if you're going to build them otherwise, is kind of one of the new challenges. You really need to be able to just regenerate pipelines, regenerate codes, and pipeline as code is one of the new hot topics. Now there's a couple of alternatives to do that. The two most popular today are the Jenkins Job DSL and the pipeline plugin. Pipeline plugin is a Jenkins file. And we looked at both of them to do this. And we kind of ended up with the Job DSL because we figured out it was much more, you could do much more reuse of the code. And when we started out using it, it had much more features and was much more elaborated than the pipeline plugin. Pipeline plugin is slowly moving forward. It's becoming more and more popular. But what we did with this project was the Job DSL. So that's the one where the DSL is right here. We had a full Puppetized Jenkins set up. So what we did is we basically, with that Job DSL, had pretty much all of these are generated. In a typical job, there's the things you expect in a Jenkins job, like how many artifacts do you keep, where the source code is, when to trigger the build, labels on where to run them, and then typically there's also steps which could be Maven, which could be shell steps, which could be all the typical build steps in a Jenkins job, and then also the different publishers. And those publishers are typically publish a build, trigger another downstream build, archive the artifacts, and all of that stuff. So, in short, this is an example of what a dashboard build looks like. It takes a git checkout, it triggers every 5 minutes, it runs only on nodes with Docker, and it actually triggers these build publishes, clones the workspace, archives the artifacts, and then triggers the next build, the next test. And that's how they now completely generate pipelines, and they completely generate all kinds of pipelines. They've eliminated now stuff like the promoted build plugin, which was really painful. Now they get a clear visual on where to click, what the next step is in a pipeline. One of the huge problems they had was you have one project, you make a small modification, you forget about those modifications and all the other projects. And by doing this in code now, they've actually moved forward to just regenerating all the pipeline. And it's all now versioned and in Git, and that's a huge advantage. So that's, in short, what they solved with the Jenkins DSL. And what they solved with the containers is that now they can actually build multiple versions of their applications. They now have smashing and dashing next to each other testing. They have different PHP versions for other applications. They're now slowly adopting to pull more functional tests and run those functional tests in containers. And they can just trigger those pipelines automatically. So next to that, the same artifacts that are built, the same containers that are built to actually run the tests in, those containers are now also slowly being adopted by the developers to run their tests in. They were using Vagrant before, but not all of them were happy with Vagrant, mostly because of speed, mostly because of running Vagrant VirtualBox on their Macs, while all the Linux guys were basically running Vagrant and didn't see a performance issue. But the Mac and the Windows users weren't really happy with it. And now they can actually run the same containers. So the big step forward for this project was that a lot of people got involved and got exposed in using containers for the first time. They saw the benefits, they saw the drawbacks. They also saw the fact that a bunch of servers still need to be rebooted every month, or actually even every week currently, because of file system issues and kernel issues. But at least now they know before they move completely to production with it. So that's also a really good thing. And that's how we introduced containers in a pretty large government organization for the very first time. Any questions?